Good day everyone, I'm Ganjoria CM Sarada from PSCS3 BGB, and in this video, I'm going to explain the rules of communication. So, in rules of communication, we have 5 rules of communication in networking. First is message encoding. Message encoding converts data into signal for network transmission. Second is message formatting and encapsulation. Structures and wrap data for proper delivery. Third is message size. It limits how much data is sent in one packet. Fourth is message timing. It controls when and how fast data is sent and received. And lastly, we have message delivery options. It defines how data is sent, like unicast, multicast, or broadcast. So now, I'm going to explain the rules of communication in networking using Cisco Packet Tracer. As you can see, this is our network setup. We have wireless router connected to a server, a laptop, and a switch. The switch is connected to 3 desktop PCs, PC0, PC1, and PC2. So first, let's talk about message encoding. Encoding is the process of converting information into a form that can be transmitted. For computers, messages are encoded into binary, ones and zeros, so devices can understand them. In our network, when laptop sends a message to the server, that data is converted into binary and then encoded into electrical or wireless signals before being sent through the router or switch. The receiving device decodes it back into readable data. And this shows that without encoding or decoding, devices wouldn't understand each other even if they are connected. Next is message formatting and encapsulation. Formatting defines how the message is structured, like a letter with a sender, receiver, and a message body. Encapsulations happen when each layer of the OSI model adds its own header or information. For example, when PC0 sends data to the server, the application letter creates the message. The transport layer adds a TCP header. The network layer adds an IP header, and the data link layer adds MAC addresses. This way, the data is properly wrapped or encapsulated, so it reaches the correct destination. So now, let's talk about message size. Each network has limits on how big a message can be. If the data is too large, it is divided into smaller packets. For example, if PC1 sends a large file to the server, the router will automatically break it into smaller packets. Each packet is numbered so that the receiver can reassemble them in the correct order. And this ensures that even large files can travel efficiently without overloading the network. So the next rule is message timing. This defines when messages can be sent or how devices handle delays. In our network, devices use protocols like CSMA-CD for wired or CSMA-CA for wireless. This is to avoid sending messages at the same time. If 2 devices send data simultaneously, the system detects collisions and resends message. Proper timing ensures smooth communications without data loss or congestions. And now, lastly, we have message delivery option. This refers to how messages are sent, unicast, multicast, or broadcast. In our setup, when the server sends data to specific PC like PC0, it means that is unicast. And if the server sends updates to multiple selected device, it means that is multicast. And when it sends a network-wide message to all connected devices, that is broadcast, which is all PC0, PC1, and PC2 that connected